Since I deal with fire and combustion on a daily basis, I thought I'd share with you the science behind my job. Perhaps you haven't noticed, but combustion is everywhere. Humans long ago learned to harness the burning or combustion phenomena and turn it into machines that we can use every day. Since there are loads of ways for combustion to occur, we'll focus on fire. Fire is a type of incomplete combustion, which means it leaves behind some sort of carbon or soot. There are three things that need to be present in order for combustion to occur. The first one, an oxidizer. Here we'll go with oxygen. The second, some sort of fuel type. Third, heat. This heat source can come from a multitude of things, from lightning to the tailpipe of your car. That needs to be above the flash point for the fuel we're using. This is an exothermic reaction, so it ends up producing some sort of exhaust. In fire, you'll get a combination of carbon, carbon dioxide, and water, and it presents itself as smoke. And heat. That heat produced creates a chain reaction, and the whole thing starts over again. Since fire can't occur without all three of those elements in place, if you take one away, the fire goes out. Firefighters typically use this to their advantage by taking away the fuel. In fires, the fuel is the vegetation the fire is burning in. We'll typically scrape it away or burn it. Or by cooling down the fire, so that the heat required to build up the fuel to its flash point is not enough to continue the chain reaction. Some examples of this are application of water, removing the heat faster than the fire can produce it. Application of a retardant substance which delays the chemical reaction until the rate of combustion is too slow to maintain the chain reaction. And when those options are not available, stirring in some cold dirt will also slow down the reaction. Unfortunately, there's too much oxygen out in the wildland setting in order for us to be able to suppress it that way. So those other two options we'll have to do. So now that we understand what is needed for combustion, let's take a look at the phases of combustion for solid fuels. The first phase is the preheating phase, in which unburned fuel is heated up to its flash point, a temperature which organic compounds expel enough vapor to ignite in air. There are three types of preheating. The first one is convection, or transfer of heat through the air. The second, radiation, transfer of heat through rays from the fire or sun. And the third, conduction, transfer of heat through direct contact. The second phase is often called the gaseous phase. This is when the vapors from the preheating phase are mixed with air and ignited, and enough energy is produced in order to make flames. The third phase is the charcoal phase. This is when the solid fuels are not outputting enough flammable gases in order for a persistent flame to continue, so they just end up smoldering. Combustion is one of the oldest chemical processes known to man, so I hope I've opened your eyes a little bit more to something that we all are so very familiar with.